Good evening, one and all. Today we will discuss about digital signature, digital certificate, and so on. Before that, digital signature. A digital signature is an electronic form of a signature that can be used to authenticate the identity of the sender of a message or the signer of a document, and also ensure that the original content of the message or document that has been sent is unchanged. So here, this is like ordinary document. When there is a document, for the document, there is a need of signature. Then only that document is prepared by us. It indicates the document is prepared by us because at the end of the document, we have signed on the document. Similarly, when we are sending a message to our friend or some other person, then there is a need to send a message as well as a digital signature. Then only the receiver will check the received message is authenticated message or not. Right, okay, with the help of digital signature. But here the question is, suppose two users are there, A and B. A is trying to send some message to the user B with the help of public key cryptography algorithms, or just assume. So, in such scenario, when the user A encrypt the data with private key of the user A and sends the message to user B. Immediately, the user B decrypts the data with the help of public key of the user A. This is the regular procedure. This is nothing but RSA. Right, okay. So in this scenario, in between A and B, when there is a hacker, the hacker hacks the data from the message from user A. Also, hacker hacks the keys, private key and public key of user A. Then the hacker simply changes the message and simply creates his own private key and public key of the hacker. Then the hacker modified message encrypted with the private key of the hacker, and the hacker sends a modified message and the public key of the hacker. So in this scenario, the hacker pretends like the user A. So automatically the user B receives the message, and the user B decrypts the message with the public key of the sender. Sender means here it is a hacker, and he can get the plain text, and he can read and understand the message, but that message is modified, altered message, not the original message which was given by the legitimate user A. So this is the problem when we are using the public keys, private keys in a public communication channel. So this is the main drawback when user A and user B communicating through public communication channels, even though it is symmetric key cryptography or asymmetric key cryptography, whatever it may be. So that is the main drawback. So in this scenario, definitely there is a need of one third party. The third party is called a trusted center. Right, okay. So the trusted center is called certificate authority, certification authority. So here now, what are the digital certificates? A digital certificate is a digital file that certifies the identity of an individual or institution or even a router seeking access to computer based information. It is issued by Certification Authority CA and serves the same purpose as a driver's license or a passport. Just you know very well, in the case of passport, the passport is given by third party, trusted third party. Here, trusted third party is nothing but the government. In the case of two-wheeler license or four-wheeler license, whatever it may be, it is given by third party trusted center that is under the control of government. Okay, so here, so whenever the user A or user B, whenever they want to communicate with other user, definitely there is a need to share the public key of the sender. So here that is a regular one. But when we take the help from certification authority, here certification authority is the responsible to exchange or to share such public keys. Is it okay? So that is the main advantage from the certification authority, because the certification authority is responsible and it takes care about such sharing of public keys. Right? Okay. So as an individual, we can't give more security to our communication. But as a certificate authority, definitely they will take care about the public key, private key, means sharing of such keys. Is it okay? So here, this is the pictorial representation. It is created by a certificate authority. Certification authority is the trusted third party, and here you can find certificate authority, and certificate authority uh, issues certificate authority issues digital certificate, and that is nothing but authenticated party. Here, certificate authorities. A certificate authority is a trusted agency whose central responsibility is to issue the certificate, revoke the certificate, renew the certificate, and provide directories for digital signature certificates. According to Section 24 of Information Technology Act 2000, certifying authority means a person who has been granted a license to issue digital signature certificates. Okay, this is like one type of agency only, and their main responsibility is to issue, revoke, renew, or provide directories for digital signature certificates. Okay, that is like licensing authority. Okay, so what are certification authorities? Certification authorities are digital world equivalent to passport offices. They issue digital certificates and validate holders identity and authority. Is it okay? Next, what is the process of obtaining a certificate? Suppose user A and user B wants to communicate each other. So here user A is the sender, user B is the receiver. So in this scenario, the user A wants to communicate with user B, then user A generates a private key and a public key pair. This is a regular practice in public key cryptography and applies to certification authority for a digital certificate with the public key. Definitely, the sender should give public key of the sender to the certificate authority for getting digital signature from the certificate authority. That is about first point. Second point, certificate authority verifies a subscriber's identity, means sender's identity. Definitely, they are responsible. They need to check whether the sender is a legitimate user or one type of hacker. If he is a legitimate user and issues digital certificate containing the public key, then definitely they will take care and they will issue digital certificate which contains the public key of the sender. Okay. Third point. And certificate authority publishes certificate to public on that is like online repository. Okay, that is like public. Means suppose they want to share the public key to a group of people. Definitely, to that group they will share all certificates. And fourth one, subscriber signs the message with the private key and sends message to a second party. Means suppose user B. Means user A subscribes, means signs the message with the private key and sends the message and digital signature to the user B receiver. And fifth one, receiving party verifies the digital signature with sender's public key and request verification of the sender's digital certificate from means certificate authorities public repository. Means definitely after receiving a public key, the user B again they need to check really the public key is belongs to legitimate user or any hacker with the help of certificate authority. Then the certificate authority will issue and will check whether the public key is legitimate user public key or some hackers public key. Then the sixth one, repository reports status of subscribers senders certificate. So definitely the repository reports the status of the sender certificate. This is the pictorial representation. Suppose uh, different elements are there. Bob's identity information, Bob's public key, and certificate authority, private key, digital signature, certificate for Bob's public key signed by CA. Here, there are four main types of digital signatures certificates. First one, server certificates, personal certificates, organization certificates, developer certificates. Okay, so here, what type of data is available in digital certificate? The first one is personal. Suppose when he is a person or he is an organization, definitely their name and email address, a serial number, public key, and validity, and the last one is digital signature. This is the example of a certificate. Usually, you might have observed many times in your laptop or desktop while using internet. Usually, it is displaying different types of certificates. First one, suppose there is a serial number, means that is unique to the issuer. Serial number like 1 2 3 4 like that. It is a big number, hexadecimal format. And one more, certificate owner. Who is the certificate owner? Here, the certificate owner is very signed, and information about certificate issuer, that is also here very signed, and valid dates. Valid date means the certificate is valid up to which month, which date, and which year. Is it okay? And the last one, digital signature by issuer. What is the digital signature? Certificate fingerprint, some miss entry is there. That is digital signature by the issuer. Now, why they are used? There are four main uses. First one is providing the identity of the sender of a transaction. Suppose when there is a transaction, the transaction means that is the communication between two parties. Here, two parties they need to prove themselves they are legitimate users. Okay, that is about first point. Second point, non-repudiation. Definitely, earlier also we have discussed when we send any mail to our friend, definitely uh, we can't deny we have not given that mail because proof is there, proof is with trusted third party. Definitely you can't deny you have not given that mail. Similarly, after receiving, the receiver cannot deny he has not received any such mails because proof is available with the server. Or suppose there is a Gmail Google server, there is Yahoo Mail, Yahoo server. Everything is proof is available with the server. Okay, in such scenario, definitely you can't deny. That is nothing but non-repudiation. We can expect non-repudiation from this concept, certificate authority and digital signatures. Next, third one, encryption and checking the integrity of the data. Provide the receiver with the means to encode a replay. Means encryption, checking the integrity, these things can be implemented. And fourth one, single sign-on. Well, just you know very well, when there is an employee in an organization and when the employee is trying to access the same server for multiple times, like say 50 times or 100 times, Definitely, there is a need to provide the credentials for accessing such a important server. It means the server may contain some confidential data or some important data. In such scenario, we can give credentials one time or two times, but 50 times or 100 times, it is very very difficult task. It is very not possible. Every time giving credentials, it is not possible. So in such scenario, it is very helpful because first time we need to give credentials. From second time onwards, no need to give any credentials again and again. That concept is called single sign-on. So you can what is that? You can expect single sign-on concept with the help of certificate, digital signature, and certificate authority. And Okay. Public key, private key pairs is comprised of two uniquely related cryptographic keys. Public key is made accessible to everyone, whereas a private key remains confidential to its respective owner. Suppose myself is the user, so definitely I need to create a pair of keys, private key and public key. In such scenario, definitely private key should not be shared with any person, but private key and public key should be accessible to everyone. Since both keys are mathematically related, only the corresponding private key can decrypt their corresponding private key, public key. Okay, so here. How do you obtain an individual's public key? When Alice wants Bob's public key. Suppose when user A wants user B public key. First of all, the Alice gets Bob's certificate from Bob or somewhere else. Okay. Second one, apply CS public key to Bob's certificate and get Bob's public key. Is it okay? Because the apply certificate authorities public key. Then the certificate authority has the public key of the Bob. Is it okay? So this is the overall procedure how to get those keys. And here, where are the certificates are used? First of all, secure socket layer SSL, and second one, SMIME, secure multi-purpose internet mail extension, and third one, set secure electronic transactions. That is one type of protocol, and fourth one also IPsec, internet protocol secure standard. Yes, sir. How digital certificates are used for message encryption? Is okay. Just you know very well what is a message encryption, and also you know very well about digital signatures or digital certificates. But here the point is how digital certificates are used for message encryption. Okay. Here message body. Second point is recipients public key retrieved, recipients public key retrieved, and one time session key is generated, and message body only encrypted with the session key. Next, session key is encrypted with recipients public key, and session key is appended to encrypted message. Then message is sent to the receiver. Okay, just once again, when there is a message, suppose some email or some other message is ready, that is first point. Second one, then recipients public key retrieved. Suppose user B is the recipient, then we need to get the public key of the user B. Then there is a need to generate one session key, and that session key is valid for that particular session only. Is it okay? Next one, message body encrypted with the session key. Suppose there is email content, that email content will be encrypted with the like OTP. That is like one time session key. That's it. Next, session key also encrypted with the recipient's public key. Session key also we need to send to receiver. So in such scenario, session key should be encrypted. Then session key is appended to the encrypted message, and a message will be sent. Why do I need a digital certificate? Okay, so here virtual malls, electronic banking, and other electronic services are commonplace, offering service from the luxury of one's home. So here, in all these things, when it is a public domain, definitely a digital certificate plays a vital role. And this is the example, and okay, these are different types of. Okay, what are the advantages of digital certificates? Decrease the number of passwords a user has to remember to gain access to different network domains. Just earlier also I have given one point. Single sign-on. Single sign-on means when we are trying to connect with a server for multiple times in a day. Definitely, every time we need to give credentials. Every time giving credentials, it is not a easy task because means giving credentials, then it checks whether credentials are correct or not. For doing all these things, it takes time. So that is the reason single sign-on concept has been introduced. So here, the first point also almost similar. Decrease the number of passwords a user has to remember to gain access to different network domains. Nagichi. So definitely, so here, miss remembering different types of passwords, it is very difficult task because suppose some 10 servers are there. Remembering 10 different passwords is a little bit difficult. To avoid such difficulty, we need to use a digital certificate concept. Second one, they create an electronic audit trail that allows companies to track down who executed a transaction or accessed an area. Next one, uh, okay, this is the conclusion. Suppose conclusion of digital certificates. The strength of digital certificates through X.509. Okay, so here this is a very popular certification, that is X.509. In next class we will discuss. And the next concept is digital signature standard. So here actually it is published in 1991, and it uses Shah hash algorithm, and DSS is the standard, DSA is the algorithm, DSS is the standard, DSA is the algorithm. So these are different points related to digital signature standard. Okay, so here, a digital signature algorithm creates a 320-bit signature, and with 512 to 1024-bit security, and it is smaller and faster than RSA. This RSA also there we have discussed many times. And a digital signature scheme only, it is like a digital signature scheme only. Security depends on difficulty of computing discrete logarithms and variant of Elgamal and Schroner schemes. So these are the pictures. Miss digital signature algorithm, there are two approaches. First one is RSA approach, second one is DSS approach. Just all of you check these diagrams clearly. First one, RSA approach. Here, RSA approach means suppose there is a message. From that message, there is a need to generate one hash code H. Okay, just earlier also we have discussed about hashing, hash code, and so on, and MAC and message digest. All these things already we have discussed earlier. So here H is hash code, then it generates some output, and here encryption. We need to apply RSA algorithm. For that algorithm, output of the hash code is the input, and one more input is PRA. PRA means that is private key of the sender. Private key of the sender. Okay, that is. So anyway, it gives some output. Okay. So here, total, we are expecting two outputs. One is message. Second one is output from the encryption. So these two elements will be transferred to towards receiver. So after receiver, the receiver will get two elements. First one is message. Second one is uh, encryption of message hash. Okay, message hash with the private key of the sender. Then again, the encrypted value of hash will be decrypted with the help of public key of the sender, that is PUA. Then it gives something. Then from message also we can generate hash code, and the generated hash code and the calculated hash code, if both are same, then automatically it proves the message is a original one, and it is authenticated message. Otherwise they will discard the message. Okay, that is about RSA approach. The second one, that is DSS approach. DSS means digital signature standard approach. So here all of you check it. When there is a message, from the message you need to calculate the hash H. Okay, you need to calculate the H, and after that you can find one function, that is digital signature. For the digital signature, total four inputs are there. One input is K. K is some random number. And the second input is output of the hash function H. Output from the hash function H. And the third one, PUG. PUG means public key of the global variable. Global, public key of the global, G. And fourth one, private key of the sender, A. Okay, private key of the sender, A. So by taking all these four inputs, it generates some output. So that output along with the message will be given to the receiver side. Then the receiver will receive these elements in the form of three elements. First one is message, second one is S, third one is R. From the message M, it generates, means the receiver can generate hash code like earlier RSA, and from S they can get X directly, and from R they can get R directly. And here all of you check it. One verification function is there. For the verification function, total five inputs are there. First one is R, second one is S, third one is hash code of the received message, fourth one is public key of the global, fifth input is public key of public key of the sender, A, PUA. So total five inputs are there. Those are the inputs to the verification function. Then it gives something, some output. That output will be compared with the received value R. Okay, if both are same, then automatically it proves the integrity and authentication of the message M. If both are not same, definitely the sender is not a legitimate user, and there is no integrity. It means the sending message and receiving message both are entirely different. Okay, so for the same thing, these are the some calculations. Both have shared global public key values, that is PQG. Here, select Q, that is 160 bit, and select a large prime number, that is P. P is equal to 2 power L. So here L is 512 1024 bits and is a multiple of 64, and Q is a prime factor of P minus 1. These are some conditions. Okay. Next one, choose G. Select G. G is equal to H power P minus 1 by Q. H power P minus 1 by Q. Here, the condition is where H less than P minus 1, comma, H power P minus 1, comma, by Q mod P greater than 1. Okay, these are different conditions for selecting G. Next one, user choose private key and compute public key. Here, select X less than Q and compute Y is equal to, please, you can select X, but you need to compute Y. Y is equal to G power X mod P. G power X mod P. Then, to send a message M, the sender generates a random signature key K. Already I told K is a some random number that is K less than Q. Next, NB dot K must be here, that is like K must be random number and be destroyed after use and never be reused. Okay. Next one. Then compute the signature pair R comma S. R is equal to G power K mod P into mod Q. Okay, that is like G power K mod P, then mod Q, then you will get R. Then what about S? S is equal to K power minus 1 dot H of M plus X dot R mod Q. Okay, these are some calculations, standard calculations for getting the values of R and S. Then sends the signature R comma S with the message M. Okay, then in receiver side, the receiver will receive M and signature R comma S. What is the verification? Already you have observed for verification function, it is taking four different types of values. So here, what are those? W is equal to S power minus 1 mod Q. W is equal to S power minus 1 mod Q. Second one, U1 is equal to H of M dot W mod Q. Next, U2 is equal to R dot W mod Q. Next, V is equal to G power U1 dot Y power U2 mod P mod Q. So after calculating all these values, if V is equal to R, then signature is verified. Okay, so that is the final version of a verification. Is it okay? So these are different points related to DSS.